Hello, my favorite people in the whole world. Oh man, I sure wish we were in the classroom. I love having fun with my students. But today we're going to do something really exciting and we're going to go over this central tendency and dispersion lesson. So let's get to it. I'm going to click it, go down here and click that to open it and click enable editing and poof. And then I'll fill up the screen with it. So there are three measures of central tendency: the mode, the median, and the mean. The mode you probably have never heard of. It is the value or the score that occurs the most times. That's all. The median is the middle value in a distribution. So if you have 100 values that are numeric, 1 through 100, the median is going to be the middle value in that entire range of numbers. And then the mean, is an average, and you all know what that is. Take all the ages of all the students in this class and add them all up and divide by the number of students, and you have the average age or the mean age. So the mode is the score or category that occurs most often in a distribution. It is the value of the most frequent score. It's not how many times it occurs. So here's a line of numbers. And if you look at it for a couple seconds, you can see that there are 4 ones and no other number occurs 4 times. So in this little tiny distribution of numbers, the mode is 1. There can be more than one mode in a distribution. If I put a comma after this 3 and then typed another 4, then there would also be 4 4s, so that would be a bimodal distribution with 1 and 4. Wow, that sounded so professional. The median, again, is the middle point or the middlemost point in a distribution. The median cuts the distribution or the line of numbers into 2 equal parts. Half of the numbers are below the median, half are above. And here is the Titanic formula to find the position of the median, n plus 1 divided by 2. If I haven't told you already, n stands for the total number of values in a distribution. So you're going to just add 1 to that number and divide it by 2, and you will get the position of the median. You will not get the median. So let's look down here with an odd n, or number of cases. The median falls exactly in the middle of the distribution. So here I have 7 numbers. And if I apply this formula, 7 plus 1 divided by 2 is 8 divided by 2. So the position of the median is 4. 1, 2, 3, 4. And in this little line of values, the median is 16. If you have an even n, or number of cases, the median is the point above half the cases and below half the cases. So here I've added another number on the end of this line, and we need to use this formula again, right? Now there's 8 numbers. N plus 1 divided by 2, 8 plus 1 divided by 2, 9 divided by 2 equals 4.5. So there is no 4.5th space or position on this line. So what you have to do is take the 4th, in this case anyway, take the 4th and 5th numbers, add them, and divide by 2. So we add 16 and 17 and get 33. And if we divide that by 2, then we get 16.5. And that is the median, in this case, when we have an even number of cases. The mean, like I said, is an average. You've heard that all your life. The sum of a set of scores divided by the total number of scores. Here is the formula for the mean. The x with the bar over it, that is the symbol for the mean. And then it is the sum of the values, right? Here's this totally cool looking sigma thing. And that when you see this sigma, that's the Greek symbol sigma, you add everything in front of it. So the mean equals the sum of all the values in a distribution divided by the number of values. Okay? With me so far? How could I possibly know that? But you'll get it, I promise you. So here's an example with donations in dollars. There are 1, 2, 3, 4, 5, 6, 7 values here. And I want you to tell me what the mode and the median and the mean are. Is that correct? Yeah. So while you're calculating, I'll tell you why are these 3 values important? Because you can lie all day long with statistics. I wanted to type something else there, like you can lie your you-know-what off with statistics, but I don't want any record of this. That's another terrible thing about not being in the classroom. I can't just say whatever I want. Okay, so what is the mode? Well, 5 is the only number that occurs twice. So that is the mode. What is the median? Well, there's 7 numbers, and 7 plus 1 equals 8 divided by 2 equals 4. So 1, 2, 3, 4, that means 5 is the median. That's what I would certainly think if I had never done any of this stuff before. But actually, when you calculate a median, the first thing you have to do is reorder the numbers so they're in sequential order. And it doesn't matter if you go low to high or high to low. So if we reordered this line of numbers, it would be 5, 5. Oh, excuse me. Let's start over again. 2, 5, 5, 10, 15, 18, 25. And then 10 would be in the 4th place. So the answer for what is the median for this little distribution, the median is 10. The mean, if you add all these numbers, you're going to get 80, I think, right? 40, 50, 70, 80. Yeah, and if you if you divide by 7, then I think you're going to get 11.4. Hold on 1 second, please. Yeah, you'll get 11.4 and a million other numbers, but it rounds off to 11.4. So the mode is 5, the median is 10, and the mean is 11.4. Boom. Here's something that happened to you the whole time you were in K through high school. When you are in school, there are other schools in your district. In fact, there are other classes, 6th or 7th grade classes when you're in middle school. So if a school wants to find out how students are doing compared to other classes or compared to other schools in the district, they have to calculate what is called a weighted mean. And the reason why they have to do that is because all classes don't have the same amount of students, or they may not have the same amount of students. So you can't just add these average grades up for each class and divide by 3 and get an accurate count. So you have to calculate a weighted mean. And, in class A, B, and C, you have all the information you need to do this except the total number of students in all 3 classes, right? Which if you add these 3 numbers up, you're going to get 104. And that extra number is what you need in the formula. And the formula, honestly, is really simple. You're going to take one class at a time. So look at class A. They have 26 students and an average grade of 92. So here's class A right here before the plus sign. So there's their average grade, and you're going to multiply that by the number of students in the class divided by the total number of students. And then you're going to do the same thing with class B. Here's class B's average grade. Here's the number of students in their class divided by the total number of students. And the same thing for class C. The average grade, the number of students in class C, and divided by the total number of students. So basically you have each class separated by a plus sign, and then when you're done with all your calculations, you just add up the numbers that you come up with. 83.48 is what I get. Let me know if you get something different. I mean, something wildly different. Don't email me and say, hey, I got 83.49. Because maybe we're rounding a little bit different. And then the second question is this the same as just adding the 3 average grades and dividing by 3? I can honestly tell you in this example that that will not be the case. But on the midterm, this is what I'm going to ask you. I'm going to give you a weighted mean problem, and you're going to have to calculate the weighted mean. That'll be one answer. The second answer is you're going to have to tell me whether or if this is the same as just adding up the average grades and dividing by the number of classes. And the only way you can say yes to the second question is if this number is exactly the same as this. But fear not, I can come up with some pretty close numbers. Okay? One more thing about weighted means. When you're working out the problem, when you calculate the individual classes, I want you to keep the numbers only 2 places to the right of the decimal point, kind of like this. Because when you calculate class A, you're going to get, as you know, with a calculator, some number like 19 point, and then there's going to be about 9 numbers after it. So just round it down to only 2 numbers past or to the right of the decimal point for each class, and then add them up. Okay, that way you won't go insane trying to add up gigantic numbers. Okay, and on we move to measures of dispersion. These are numbers or numerical values that best represent how the data is spread around the measures of central tendency. It's really cool to know the mean, but it's way more cool to know the mean and the standard deviation. Okay, so here's a formula called a raw score formula for standard deviation. And when you see on the midterm or on the problem set a standard deviation problem, I want you to immediately write out this formula. This is the formula for standard deviation. The small s is the symbol for standard deviation. You know, once again, we have this sigma, which means that you have to add everything in front of it. So you're going to, this is the sum of the squared values. That's my cat if he starts meowing. Divided by n, which is the total number of values, minus the mean squared. So I'm going to take all 3 of these values out. Here's the mean squared, the sum of the squared values, and the n. You know, this way, then I think it's easier to look at it, you know, as only solving for individual items. So here we go. See this column of numbers? That's what you're going to look at when you see a standard deviation problem. So the first thing that you're going to have to do is find the sum of this column of numbers and the sum of the squared values, right? This is important that you think of it this way, the sum of squared values. So I'm going to take this original column of numbers and I'm going to square each number, and then I'm going to add that column. Now, if I said the sum of the values squared, that would make me think that I would want you to square 30. And that would give you 900, which is a way bigger number than this. You don't want to do that. So just remember, the sum of the squared values, each value individually squared, and then added up. So 202 is what we get for the sum of the squared values. And then you have to find the mean and square it. Remember the formula for the mean. The sum of the values divided by the number of values. So for the sum of the values, we're going to add up the original column of numbers and get 30. And we have 1, 2, 3, 4, 5, 6 numbers, so that's the n. So 30 divided by 6 equals 5, which is not what we want. I mean, that's the mean, but what we want is the mean squared. So we have to square 5, or 5 times 5 equals 25. And now we have the mean squared. Bada boom, look at that. So look, there's the mean squared, like we broke it out before into these 3 individual items. Mean squared is 25. The sum of the squared values is 202. And the n, or the total number of values, as we just saw, is 6. And then all we have to do is just plug in these values over here. So the sum of the values squared is 202. The n is 6, and the mean square is 25. And look what I'm doing here, right? Almost forgot to tell you. The standard deviation formula has a square root sign, so I'm bringing it down through the entire problem. So if I calculate this, I get 8.67, but I still have the square root sign, so I'm not finished until I take the square root of this number, which gives me 2.94. And that is the answer, the standard deviation for that original column of 6 numbers. Boom. A few other measures of dispersion, or just measures, ratios, are going to be on the midterm. It's just one frequency divided by another frequency. Like the ratio of female to male students at CSUSM, the percentage of female students is 68. The percentage of male students is 32. So all you need is this fraction, except, you remember from grade school, what can you do with fractions? You can reduce them. So I may give you this fraction on the midterm, or I may give you a fraction that is reduced all the way down. Like if I divided this by 2, it would be 34 over 16. And if I did it again, it would be 17 over 8. And I think that's probably as far as I could go. 17, right? Yeah. Okay, so beware of that. I can reduce fractions. Also, proportions and percentages. I'm going to ask you questions about those two things. They are identical numbers. They're just expressed differently. So a proportion of 0.79 is the same as 79%. Just be careful if I give you a word problem and I'm asking for proportions to look for numbers that look like this. Same thing with percentages. If I ask you the percentage of some group, look for numbers with a percentage sign. Okay. Outliers. Values too big or small, or too distinct to logically fit within the distribution. In certain cases, like with the mean or the average, outliers can really skew the results. So the mean age of a group of college students will be negatively skewed by one value of 1 instead of 21. If somebody's doing data entry and they're supposed to enter 21 and they hit 1 by mistake, then that's going to make the mean go down. The mean home price will be positively skewed by one value of 300 million instead of 3 million. If somebody's supposed to enter 3 million and they enter 300 million, that mean is going to shoot up a lot. Which is probably why when they talk about home prices in San Diego County, they always talk about the median home price, because the median will not be skewed at all by outliers. Wow, I bet you didn't know that, huh? Okay, so there is a central tendency and dispersion problem set in this week's class, and I will make another video for those. So I hope you enjoyed this, and maybe you heard my cat meow. Okay, see you soon.